everyone. Sometimes I get a little gray-haired and senile. Not really senile yet, but I'm sure it's coming due to all the blows to the head I have taken from all the numerous sports I choose to play. And because when I was a kid, you didn't wear a helmet for nothing. Which of course made us actually more careful, and we got less injured than you guys who wear helmets for everything. Which is kind of weird when you think about it. Mr. Zaro. I've played rugby almost every week of my life since 1988. Huh? By far, because it is the best sport. Every sport that you like, no matter what it is, rugby has everything you like in every other sport, all in one. Huh? So let me get this straight. You actually like dropping the ball? Okay, fair enough. That's true. I personally don't like a sport where you drop the thing that you were trying to score with all the time. I just don't like that. So rugby falls short on one thing. It has no dribbling.
Did you ever try to play professional rugby?
Mason, I love the game, but I grew up in a time where you weren't told that everything was possible. Right? Yeah, you can. Yes, you can. Yes, you can. As long as your arm is straight by the time it hits the body and it hits below the face. Same as football. You can't stiff arm in the face mask in football. You cannot put your...
As long as your hands are closed on the face mask.
No, that's stupid. But that's because you guys have to wear armor. It's fair enough. It's okay. You're allowed.
It's so we can hip harder.
No, it's so you can not learn how to tackle. It's so you can learn how to hit. So you can run into things really hard. That takes a lot of skill. Tackling takes skill. Which is why the Seahawks, the best defensive team in the NFL for the last 5 years, guess who coaches them tackling? Rugby players. You know why? Because we know how to tackle. We don't just run into things. Well, I know you do. All right. It is irrational, but I said I wanted an estimate from your notes. 576 is way bigger than everything that was in your notes, wasn't it? No, because in cube roots we went up to 100 or 1,000, right? 576 is between what and what? 8 and 9. 8 and 9, which is 512 and 729. Now, that's about 200, right? Right? And 512 to 576 is about 50, right? So it's 8 and 50 out of 200, which is 5 out of 20, which is 1/4. So a good guess for this would be 8.25 or 8 1/4. Eventually that will show up. There it is. I only drew the 8 17 times. 8. There is, we already talked about B. We already talked about C. So let's talk about D. Right? Now, D is a lot like B, correct? We know that 1,000 has a cube root of 10, yes? Right? Now, we also know that 2's cube root is 8, yes? So what do you think is the cube root of 20? Or the cube of 20? What's 20 times 20 times 20? 8,000, right? So it's just like B. 3,000 is real close to 1,000, right? It's 2.5 steps out of 8 steps, right? So it's just a little more, it's like a third, yeah? So it's 10, and then it's a third of the way to 20. Well, there's 10 steps there. A third of 10 is 3 and a bit, right? So it makes good sense that this is 13 and a third. Everybody with me? Is it? You can check. With what? I'll get it. Go for Myers. Yeah. So it goes. It's only math. They don't care. Uh-huh. I am indeed going to 5440. You go on to, you can do it through 5440.com. You can go on to chilliwackculturalcenter.com. I believe they're putting it on. Yeah, it's a science piece. $47. Cool. That. Wait a second, it works out to 15 exactly. Why didn't you say so? So you checked it with your calculator. I didn't even check it with my calculator. I just assumed it wouldn't be right. But my estimate of 13 is pretty close to 15, isn't it? Cool. I forgot that we should check with our calculators first. What about this guy? Yo. Oh, it's just out front. Hey, Max. E. E looks like it should work, right? Right? Does it? Does E work? It does. So you check it with your calculator and you find that it is 270, right? Why? Because that is 729 times 100. Square root of 729 is 27. The square root of 100 is 10. 27 times 10 is 270. What about this guy? Does he work? Square root of 100,000. Does it? What is it? It's irrational, isn't it? Square root 100,000. That's irrational. So we would need a guess, but that's a giant number, yes? So isn't that 100 times 1,000? And isn't 1,000 100 times 100 times 10? Do we know that square root? What is it? 10 times. Do we know that square root? What is it? Square root of 100. We just did it. 10. Square root of 10, it's just a little bit more than 9, right? Right? The square root of 9 is 3, so this must be a little bit more than 3, right? Call it 3.1. 10 times 10 times 3.1 would be 310. And the actual answer is 316. Pretty close. Cube root of 1728, you do that with your calculator, what do you get? It works perfectly, right? Yep. Emily? Of course you can, because washroom is where you learn how to do math. No, it doesn't, because it's got a decimal point in it. Again, you have to... No, Aiden, listen to me. Do you understand what I've done here? Is that a rational number? Square root of 100, is it? Is square root of 10 a 100 rational number? Okay, square root of 10? No. So rational, rational, irrational. The answer is irrational. Okay, the reason your calculator does different spacing is simply because of the numbers involved. Okay? Square root of 529, does that exist? 23, you checked it with your calculator. Cube root of 1,000, you know that's 10. Square root of this is the same as the square root of 196 over the square root of 225. 14 over 15, that's on your list. Square root of 125 doesn't exist, but it's a little bit more than 121, right? So it must be 11 point a bit. It's 4 steps past, and 121 to 144 is 23. 4 out of 23 is about a fifth, right? So it's 11.2-ish. Cube root of 64, you know, is 4. Cube root of 125. This is where things go a little crazy. What is that really? If you punch in your calculator, you get the answer. What is it? What is it if you punch it into your calculator? 0.5. Why? Because this is 125 over 1,000, right? And the cube root of that is the cube root of 125 over the cube root of 1,000, which is 5 over 10, which is 0.5. This one, 5 over 3, 1 2/3, 1.667. Now this one's tricky, because if you punch Q into your calculator, you get 1.6666667. So it repeats, right? Why does it put that 7 at the end? Yeah, because the next number is going to be a 6 and it would round up, right? And this one is irrational, but of course it is between 4 and 5, because it's between 64 and 125. It's about 2/3 of the way, so 4.67 or 4 2/3. Turn the page over. Surface area of a cube with that side length. Is this easy to do without a picture? It is. Is it easier to do with a picture? There's my cube, right? A cube has what special about its sides? Evan. They're all equal. So if that's 15 and that's 15 and that's 15, we're good, right? So what's the surface area of a cube? How many of those surfaces are there? 6. So it's 15 So it's 15 squared, because that covers one side, times how much? 6. 225 times 6, which is 6 times 200 is 1,200. 6 times 25 is 150. So 1,350. Right? And finally, calculate the surface area of a cube, but now I know the volume. So I have a cube, and I know the volume equals 216. What do I know about cubes? What do I know about every side? They're all the same, right? So since they're all the same, that means all those factors are equal, yes? What finds me equal factors? Roots, correct? But I don't need only 2 equal factors this time. What do I need? 3. So I need the cubed root of 216, which is what? 6. So x is 6. Now how do I find the surface area? 6 squared times how much? 6 squared covers one face. How many faces are there? 6, which is 216. What? How can it be the same number? Is it the same number? Yes. Is it the same value? No, because this is 216 centimeters cubed and this is 216 centimeters squared. Is everybody good with square roots-ish? Well, Max, you weren't here for yesterday, so Or, yeah. Yeah. Is everybody comfortable with using their calculators to find squares and cube roots and understanding the difference between rational and irrational? And is everybody good with using the lists to find perfect square roots and cube roots? Is everybody cool with that? Because the next place we're going to go is what to do with that, but not end up with a decimal. Does everybody understand? Right? So we already know we've done root 72 before. Root 64 is 8. Root 81 is 9. 72 is in the middle. Everyone's good with this, right? What we're going to do tomorrow is take that and do what you're supposed to do with it. Because if I punch that into my calculator, I get that crazy decimal, 8.48, blah, 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 right? Is that an exact answer? No, because that decimal goes on forever. What you guys are going to learn tomorrow is how to keep this an exact answer, which is the way you're going to do math for the rest of your math careers. Very rarely will you actually be getting the square root of an irrational number in math class. In real life, you're always doing this, aren't you? Because in real life, you wouldn't go to the store and say, I need 36 pi meters squared of carpet to put in my circular room, right? You would ask for a real number. Is everybody good? Okay. Now, the other thing you need to be able to do tomorrow is you need to be actually comfortable with exponents. All right? Not so much the exponent laws, but what exponents actually mean. So 3 cubed times 2 squared. What does that actually mean? 333 times 2 times 2. Everybody cool with that? Everybody remembers that, right? Okay. It's 11:15. Lunch is at what, 11:30? So 11:30. I actually think that the best thing to do right now, because what we're about to do is a little bit confusing tomorrow, I think we should start on it now. If we get through the lesson, you'll have no homework tonight. You can work on the work tomorrow in class. Okay? So if everybody could turn to page 96, that would be really useful. It should say simplifying radicals in kind of like an electric-y font. So we talked about this yesterday when we introduced roots. A radical, and please remember, I use the real words. A radical is an expression with that symbol in it somewhere. Now we know that symbol can mess around, right? It can have a little 3 there. It can have a 2 there. It can have a 5 there, whatever. But if it's got that symbol, it's a radical. Everybody good? All right. An entire radical. That means everything is, everything, that should say S, is inside here. Everything's inside there, under the radical sign. A mixed radical means there's a coefficient. Does anybody remember what a coefficient is? What is it? It's the number in front of whatever's coming afterwards, right? And what do coefficients do? I'll give you an example. 3x. The coefficient there is 3. What does it do to the x? Multiplies. So in radicals, there's a coefficient, 3. It'll show up in a second. 3. And I need a radical, so it's 3 root x. And that's how we read that. 3 root x. Everybody cool? So you don't need to write this down, but if it was something like this, 3 cubed root 29, that's how we would read it. 3 cubed root 29. Everybody cool? All right. Now what we're going to do is deal with that. Now we already know that that's an irrational number, yes? Because the square root of 72 is 8.481556, blah, 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 blah. Right? We don't want that anymore. So here's what we're going to do. That symbol, the radical sign, if it has no little number there, what is the little number that should be written there? 2. What does that little 2 mean? It means we need 2 identical factors, right? We already know that there is no 2 identical factors there, is there? Right? We know that. But, watch. Everybody take 72 and make a factor tree with it. You've already done a factor tree of 72, so it shouldn't take that long. Everybody make a factor tree of 72. And remember, you probably might have different branches than me, but I'm just going to go ahead and write mine out. So 72 equals 2 times 2 times 2 times 3 times 3. Everybody cool? Everyone agrees, right? Okay. So, if 72 equals this, then doesn't the square root of 72 have to equal the square root of 2 times 2 times 2 times 3 times 3? Does everybody follow that piece of logic? Everybody's good? All right. Now, what's the little number that's there? We don't write it in this case only, but what should it be? 2. Which means we are looking for how many equal factors? 2. Is there 2 equal factors? Excellent. Is that 2 equal factors? Excellent. So if I'm looking for a group of 2, do I have it right there? And there's another one, correct? Now, put what you already know together with this. And here's what I mean by what you already know. What is the square root of 4? 2. What is the square root of 4 if I put it in a product of prime numbers? 2 times 2, correct? Is that a group of 2? So we would bring it out from under the radical, yes? And the square root of 4 will equal 2 because there was a group of 2 there. Is everybody with me? Great. Now look at what we're doing over here. Is that a group of 2? So where should we take it? We want groups. We want to take that out, right? Good job, Max. So I got a 2 out in front now, don't I? Is there another group of 2 in there?
Yeah.
Where? 3. So I'm going to bring the 3 out in front. What did I have to leave under there? This 2 didn't get to come out, did it? Because he's by himself. So the 2 stays under there. Now, I already told you that a mixed radical, these are coefficients. What do coefficients do? Multiply. So what do 2 and 3 do? Multiply. 6 root 2. And that is the answer that we seek. Does everybody understand? After you do the first 2, I'm going to show you a very helpful shortcut, but only after we've done the first 2. So, what was step 1? We need to do a factor tree. So, let's start with 99 and break it down. What is it?
9 times 11.
Okay. 9 times 11. Is one of those a prime number? Which one? 11. Lovely. So we do a circle. Does 9 break down?
Yes.
Into what?
3,
3 and 3. Those are prime numbers, correct? So now, the square root of 99 really equals the square root of 3 times 11. Everybody agree? Do you see a pair in there? What is it?
3 and 2.
So what happens to the 3? It comes out front, 3. What did I have to leave under there? 11. Done. Let me ask you this. Can I make this step easier? Is there a shorter way to write it than 3 times 3 times 11? Could I not write it as 3 squared times 11? And that little 2 tells me that's my group. Everybody with me? Great. Try it with 75. Break 75 down into what and what? There's lots of options. But the one I would recommend is how many quarters in money are there in 75 cents? 3. So 3 and 25, right? Right? Okay. Is one of those a prime number? Which one? 3. So we're going to stop at 3, but what do I do with 25? 5 and 5. So let's write it out. The root of 75 is really the root of 3 times 5 squared, yes? Is that a group of 2? So what happens to it? It comes out 5. What did I have to leave under there? 3. There's my final answer. Now, I told you I'd give you a shortcut here. Here's the shortcut. What is special about the 2 things I am highlighting? What is special about the number 9 and the number 25? Aiden.
They both square.
They're both perfect squares. Everybody see? So, since I'm looking for a square root, if I find a perfect square anywhere in my factor tree, then I can stop there, can't I? Because the square root of 25 is 5, and that's what I took out front. The square root of 9 is 3, and that's what I took out front. Does everybody follow me? Yeah? All right. You guys try C, and then I'll show you how it can be done much more quickly if you're good with your perfect squares. Everybody try C. I'm betting most of your first branches are 8 and 10. Is that right? Did most people start with 8 and 10? Are either of those prime numbers? So I got to keep going, right? Let's do it. 2, 4, 2, 2. Everybody happy? So I know I've got 2 cubed under the radical sign, right? 10 is 2 and 5. So I've got another 2. So I've actually got 4 2s and a 5, right? How many 2s can I get out of there? 4? 2. And then another 2. 2 squared. And what did I leave under there? 5. What's 2 squared? 4 root 5. That's where we're going to stop. You have no homework tonight. I'm going to show you how to make that easier tomorrow.